All right, so we're now moving on to the first section of our last unit of the year. So we are almost finished. And what we're doing now is we're going to learn about rules of exponents. And this is going to be broken up into two separate videos because there's 7 rules that we need to learn and know. So make sure when we're going through this that you are writing out all the rules and naming them. And while you're answering questions, make sure you're referring back to it, right? Once you start doing some of these problems over and over again, and being able to identify how each rule looks, then it's just applying that same rule. And the more you do it, the more you use it, the easier it'll become to remember. Right? But there are 7 rules, so make sure you have these written out nice and neat when we go through them, so that this way you can refer back to it, and this way you have a nice little chart for you to apply as you're answering questions. Right? So at the end of these 2 videos, students or you will know how to apply the properties of exponents in order to simplify our expressions. Right? So it's allowing us to simplify our expressions into just one overall expression. Before we move on to the rules, there's just some things that you need to understand. So when we're talking about exponents, it is that where we have something raised to a power, right? And that small number that's written at the top of our variable or a number, that is our power. And the number that has the power being raised is called our base. So if you hear me refer to the word base, that's whatever number or variable or expression that's being raised to the power. And then our power is just that small little number that's written, that's telling us how many times we're multiplying our base together. So when we see this x to the 3rd power, what our exponent is telling us is that we are multiplying x 3 times, or we're multiplying that number that many times. So the power tells us how many times we're multiplying our base. All right, and you need to understand that our power is our exponent is written at the top, the small little number that we'll see, and our base is whatever is being raised to that power. All right, so that is the 2 things when you hear me refer to power or base, you need to understand what they're referring to. All right, so now we're going to list all 7 rules that we're going to learn, and then we're going to go through them one by one. All right, so here are the 7 rules for exponents. So we will have what's called a product property, quotient property, zero property, negative property, power of a power, power of a product, and power of a quotient. We will cover the first 4 properties in video 1, so in this video, and then we'll cover the last 3 in video 2. All right, and at the end, I'm going to display one little thing here that you should be copying down as well. So this way you have your rules nice and neat and all laid out for you in this one little area. All right, so we're now going to dive into all these rules and all these properties and start going through some examples. All right, so the first property that we're going to learn is our product property. And what this states and what it's telling us is that if you have 2 numbers, 2 variables, 2 expressions that have the same base, so you see these are both a base of x, and they're being raised to a power. When we can multiply these together and we can add the powers. So if I have x squared times x cubed, I can simplify this to say x to 2 plus 3, which we know is equal to 5. So then it is equal to x to the 5th power. So the product property is if we are multiplying the same base, we can add our powers. And we can think about why the connection is with multiplying and adding, and I'm going to show you a few different reasons of how we can make this connection. So first off, you learned back in elementary that if we're saying 3 plus 3 plus 3 plus 3, that we can rewrite repeated addition as a multiplication problem. We can say that, well, we have 4 3s and we can multiply them together. So we can see that in past learning, we have a connection between addition and multiplication when we had the repeated thing over and over again. All right, so repeated addition we can rewrite as multiplication. Well, what this is telling me, this x squared, is that I have 2 of those x's being multiplied together. So I can rewrite x squared as x times x. And then this x cubed, I can rewrite as x times x times x, because as we talked about in the very beginning of this, that power is just telling us how many times we're multiplying that base together. So if we were to expand these out and write it out like this, we see, well, since they're being multiplied in between, that we now just have x times x times x times x, or 5 x's that we are multiplying together. So the way that we can go from 2 and 3 is we can simply just add those together. Right? So we could expand this out every single time if we wanted to and count how many x's we're multiplying together and rewrite it, but that would take us forever. And especially when we have more complex problems than this, it will be way too difficult. So the rule that you have to remember is that when we're multiplying the same base, we add our powers. Right? And we can see the connection that we made through addition and multiplication with repeated addition that you learned in elementary. So when we're multiplying the same base, we simply add our powers together. All right, so now let's move on to the next property that we have. All right, so now our next property that you will need to know is the quotient property. And what this is telling us is that if we are dividing two like bases, we can then subtract their powers. But we have to do the numerator minus the denominator. All right, so you make sure that you're doing in that order. So if we're dividing the same base, we can subtract our powers. And this should make sense as well once we expand this out and talk about it like we did with the multiplication. So if I have x to the 4th power and I'm dividing this by x, well, we can expand this. I can rewrite this x to the 4th power as x times x times x times x, because that is telling me I'm multiplying my base 4 times. So I could rewrite it as x times x times x times x. And we still have that denominator of x. Well, you have learned before that when you are multiplying and dividing by the same number, that they cancel each other out and are equal to 1. So I could cancel or cross these x's out to simplify. And now I'm left with x times x times x, which we know we can rewrite as x to the 3rd power, because we are multiplying that x 3 times. So we can ask ourselves, well, how can we get from this to x cubed without needing to expand and then cross out? Because that's just going to take too much time. So just like when we have a variable x, the number that's in front of that x is always understood to be 1 as our coefficient. Well, just like that, if we don't write a power, it is also understood to be 1. So I could think about this as x to the 1st power. So to get to that, we can say, well, we can then take our base and we do our power of our numerator minus the power of our denominator. So 4 minus 1 is equal to 3. So you see, we get the same answer by applying this property and rule. So when we are dividing with like bases, we subtract our denominator from our numerator. All right, so it's important that you are going in that direction. And the reason why is when we expand them out, we would be simplifying and crossing out some of those bases. And it's eliminating them. So we can then just subtract that from the total that we have. All right, that is our quotient property. Now let's go ahead and talk about our next property. All right, so now we're going to learn about and talk about what's called our zero property. And what this is asking us is what happens when we raise something to the 0 power? What is that equal to? So in order to discuss that, we're going to use actual numbers and talk about what happens when we are raising something to a power. All right, so 2 to the 1st power, so anything raised to the 1st power, we only have one of them, so it's just equal to 2. 2 squared, I know that's telling me 2 times 2 because it's telling me how many times I'm multiplying that base, which is going to be equal to 4. 2 cubed is saying 2 times 2 times 2, which is equal to 8. And 2 to the 4th power is equal to 2 times 2 times 2 times 2, which is equal to 16. So if you noticed, as we were going up in power, we were multiplying by 2 every single time. So let's think about that in reverse. If we started with 2 to the 4th power, we know that it's 16 because 2 times 2 times 2 times 2 is 16. If I wanted to get to 2 cubed, I could multiply 2 together 3 times, or since I'm multiplying by 1 less 2, I can divide by 2 to get to 8. So if I want to then go to, well, what's 2 squared? I can divide by 2 to get to 2 squared from 2 cubed. If I want to figure out what 2 to the 1st power is, I can divide by 2. So you see, as we're traveling down that power, we can get to the next number by dividing the one above it because we're multiplying by 1 less 2. So instead of multiplying by 4 2s, I'm multiplying by 3, or I can take 16 and divide it by 2. So now, by using that same pattern, and it's what we talked about in class as well, about identifying patterns in math. Once we see that pattern, well, let's apply it then, because we see each time we're subtracting 1 from our power. We're going from 2 to the 4th to 2 cubed, to 2 squared to 2 first. So the next number would be 2 to the 0. And the pattern that we're getting is dividing by 2 every single time. So we would follow that same pattern and say, well, 2 divided by 2 is equal to 1. So what this rule tells us is anything raised to the 0 power is equal to 1. So the 0 property is telling us when we have a base that's raised to the power of 0, it is simply equal to 1. And this is why it occurs, because we are dividing by 2 every single time. So then if we are stuck at 2 to the first and say, well, what happens when it raises to the 0? Because I don't understand that. What do you mean raised to the 0 power? What's going on? Well, we can look at the pattern that's happening before it and saying, well, every other time that we went from the power above to the power below, we're dividing by our base. So that means we have to have the same pattern from going from 2 to the first to 2 to the 0 as well. So then when we divide by that 2, it's going to give me 1. So anything raised to the 0 power is equal to 1. All right, now we're going to keep this up there to finish our 4th power for this video, which is our negative property. All right, so we just talked about how we can use the patterns that were developed to figure out why anything raised to 0 power is equal to 1. So now let's think about that same pattern that was formed and how we can then apply that to negative exponents. Because all we're doing to get to the number below is subtracting 1 from our power. We did 4 minus 1 to get 3. We did 3 minus 1 to get to our next one. We're just going, well, what happens when we're 1 power below? So when we're at 2 to the 0, we can subtract 1 to get to our negative first power. But what happens when it's negative first power? Well, think about the property or the pattern that was just forming. We know that we get our next number from dividing the power above us by our base. So to figure out what 2 to the negative first is, it follows the same pattern. We just divide it by 2. Well, 1 divided by 2, 1 divided by 2 is equal to 1/2. So that means 2 to the negative first power is equal to 1/2. To go on to the next one, we're dividing it by 2 again. Well, 1/2 divided by 2 1/2 divided by 2 becomes 1/2 times 1/2, which is 1 to the 4th power. So this is now equal to 1/4. Now we have our next one. When we divide by 2, that's going to give me 1/8. And our last one, when we divide by 2, it's going to give me 1/16. I'm now going to pause this video and write our common colors next to each other to see if we can figure out the pattern. All right, so I just rewrote them all next to each other where they had the same power but different sign. So if you notice, 2 to the 4th is equal to 16, and 2 to the negative 4th is equal to 1 over 16. 2 cubed is equal to 8, and 2 to the negative 3rd power is equal to 1 over 8. 2 squared is equal to 4. 2 to the negative 2nd power is equal to 1 over 4. 2 to the first is 2, and 2 to the negative 1st power is 1/2. What do you notice happened every single time? When we have a negative power, it just changes. If it was in the numerator, it becomes to the denominator, right? It flips our base. It flips it and makes it and takes its reciprocal. So the rule that you have to know for this is if you have x to the negative power, let's just say to the negative n, that then is equal to 1 over x to the n power. So if it was originally in the numerator, it goes to the denominator and just changes to a positive power. If it was originally in the denominator, so it's 1 over x. All right, this is frozen, so I'm just going to have to write it underneath. 1 over x to the n, negative n power. If it was originally in our denominator, it then gets rewritten to our numerator. All right, so our negative property is just taking the reciprocal of that base, essentially. If it was in the numerator, we drop it to the denominator. If it was in the denominator, it moves up to the numerator. All right, so that is our negative exponent. And sorry, this should have actually been 4 and not 3. I didn't change that. But that is our 4th property, and that's the last property that we're going to learn in this video. So now we're just going to go through a couple examples with it. All right, so now we're just going to go through a few examples for this, and we're going to talk about which rule it is and then just apply that rule. So here I see that we have a division problem. We have x to the 12th divided by x to the 4th, so it's quotient. So remember, our rule is x to the m power over x to the m is equal to our power of our numerator minus the power of our denominator. So since they have the same base, that's what we need to identify first, make sure they have the same base. Then we can then say, okay, it's equal to the power of our numerator minus the power of our denominator, which 12 minus 4 is equal to 8. So this is equal to x to the 8th power. All right? What people want to do is because they see division, they want to divide 12 divided by 4, but you have to break that concept. When we're dealing with exponents, it's not just regular division. We're not doing 12 divided by 4. It is x to the 12th divided by x to the 4th. And remember, this is telling me I have 12 x's in my numerator, 4 x's in my denominator that are being multiplied, so I can simplify or cross out 4 x's in my numerator, which then is what we're doing with that 12 minus 4, right? Because if we were to expand it, we would have 12 x's being multiplied in our numerator, so we can cancel 4 of those out. So when we see, first identify, what type of problem is this? It's quotient. What is my rule for quotient? Subtraction. Then I need to look at the base and say, is the base the same? Yes, they are. Then I can go through and actually subtract. All right, so that's our first problem. Let's go ahead and do the next one. All right, this next problem, is this simply y to the 0 power? Well, anything, this is our zero power property. Anything raised to 0 power is equal to 1. So this is just simply 1. All right, so when we do this, and anything being raised to 0, it is equal to 1. So you wouldn't say 1y, it is just simply equal to the number 1. All right, even though it was a variable. We showed you that 2 squared is 4, 2 to the first is 2. 2 became 2 to the 0 became 1. So even if it's a variable and it's raised to 0, we know its value is equal to 1. So any power or any base raised to the power of 0 is equal to 1. One of the things that you need to be able to differentiate from this when we're dealing with exponents is if I say, actually, I'll do this at the end of the video. But one of the things I like to do to make sure that you're paying attention is I might give you a really hard-looking question. And if I've raised this entire thing to the 0 power, all of this is actually just equal to 1. So you don't need to do any of that. So if you see all of this is being raised to the 0 power, it is simply just equal to 1. When we go through the rest of our properties with this, it'll make a little bit more sense for you. And what I was just about to talk about with this example, about the differences, that will be talked about in our properties 6 and 7. All right, let's go on to the next example. All right, so for this next one, we have q raised to the negative 5th power. So this is our negative power property. And all we have to do then is identify where is this variable or base located. It's in the numerator right now. And we just need to rewrite it as a reciprocal. So it is equal to 1 over q to the 5th power. All right, so we identify where is it. We see the negative power, and that tells us it's then switching its location in our fraction, that if it was in the numerator, it drops to the denominator. If it's in the denominator, it moves up to the numerator. So once we see that, we have to identify where it's at right away. All right, let's move on to the next one. So for this example number 4, it now says 1 over w to the negative 3rd power. Once again, we see it's a negative power. That tells me I'm then flipping it where it's at in our fraction. So since this one started in our denominator, we would simply rewrite this as w cubed. All right, the negative power is just telling us we're moving it to the opposite location of the fraction. All right, if it was in the denominator, it moves to the numerator. If it was in the numerator, it moves to the denominator. But you have to understand that this can apply to both of them, that it's not just we only write it starting with it in the numerator, that we can then flip it back and forth between each one. All right, let's move on to the next and last example. All right, here we have a to the 7th times a squared. Once again, we identify we're multiplying these, so we're going to then use the product property. And with the product property, that tells us that when we have a base, 2 of the same bases, we simply just add their powers together. So this is equal to a to the 7 plus 2, which is then equal to a to the 9. All right, remember, this is telling us that we are actually multiplying 7 a's here. And here we're multiplying 2 of them. So total, we're multiplying 9 a's together, which is now why we have the power of 9. You don't need to expand it out. You can simply just add your powers together. All right? So that is it for this video. And we're now going to focus on the last 3 properties. And at the end, I'll give you, and I'll print this out for you as well, but I'll give you a little sheet that you can copy down that shows all the properties next to each other.